Hey there, Math Hoppers! In this video lesson, we will learn how to solve linear systems by graphing. So, linear systems, what are they? Linear systems are two or more equations that we solve simultaneously or together. And even though linear systems could have more than two equations, for this video lesson, we will concentrate only on linear systems with two equations. So if we're taking two equations and we're solving them together, the solution has to be that coordinate point that is true for both of the equations. It has to make both equations true. And if you remember, solutions to linear equations are simply points along the line or along the graph of that line. So if we were to take two linear equations, and solve them simultaneously by graphing, the solution would be the intersection of those two graphs. So right here, the linear system that is graphed here, the solution would clearly be 2, 4. That is the only point that works for both of those equations. The only point that works will be the point where they intersect. So let's talk a little bit about linear system solutions. We just saw a linear system that had one solution. And in fact, there are only three possible types of solutions for linear systems. You could have what we just saw, where a linear system has one solution. That means the two equations intersect at one point. You could have a linear system that has no solution, meaning those two equations or those two lines never intersect, they never cross, they never meet. That makes them parallel. Remember that parallel lines have the same slope. So if you're given a linear system in which both equations have the same slope, there will be no solution for that system. And the last type might seem weird. It's infinitely many solutions. This is when you get the same line. And you might be thinking, how am I going to not notice they've given me a linear system with the same equation twice? Well, they're likely going to give you two different forms. They'll give you one equation in slope-intercept form and maybe the other one in standard form. So they won't immediately look like the same line, but when you graph them, you will see they in fact are the same line and they have infinitely many solutions. Okay, so solving linear systems by graphing. Basically, if you can graph a linear equation, you can solve a linear system by graphing. And granted, graphing is not the most efficient way to solve these, but you will be asked to do this. This will probably be the first type of solution you learn, is solving by graphing. So here's all there is to it. You are going to rewrite each equation in the easiest form to graph. And we're going to say that that's going to be slope-intercept form. So y equals mx plus b form, simply because we can plot the y-intercept and then use the slope to find additional points. Once you've done that, you're going to graph each equation on the same coordinate plane, and you're going to locate the solution by locating the intersection of those two lines. Now, you might have to estimate, and this is where solving by graphing isn't the most efficient. If you don't get a solution that includes whole numbers, you could be estimating your solution on a graph. And then we are going to check our solutions by substituting the x and y coordinates back into both equations. All right, so let's get started. Let's solve the system x plus y equals 8 and x minus y equals 6 by graphing. First step, we are going to rewrite both of these equations in slope-intercept form to make them easier to graph. Now, you could argue that we could graph these by plotting the intercepts, and you could do that. But I'm going to go ahead and take the time to rewrite them in slope-intercept form. Starting with x plus y equals 8. This is really easy to move into slope-intercept form. Slope-intercept form simply means solve for y. You need y equals, we have to get rid of the x. How do we get rid of an x over here? Well, the opposite of positive x is negative x. That means we subtract x from both sides of the equation. Remember, anytime you're trying to move something from one side of an equation to the other side, you use the opposite operation. Opposite of plus x is negative x, or opposite of plus x is minus x. So we subtract x from both sides. We get y equals negative x plus 8, and we are done. Moving on to x minus y equals 6. Again, we have to get x away from the y. We have to get x from the left side of the equation to the right side of the equation. So again, opposite of positive x is negative x. Subtract x from both sides. We get negative y equals negative x plus 6. Be very careful that you don't lose. I know people think this is a subtraction sign, But look, it's a negative sign in front of the y. This is equivalent to -1 times y. So you can't just ignore this. You have to bring down that negative in front of the y. How do we get rid of a negative in front of a y? Easy. Just divide everything, including both terms on the right side, by -1. And dividing by -1 simply flips the sign of everything. Negative y becomes y, negative x becomes x, 6 becomes -6. We get y equals x minus 6. We are now ready to graph these two lines, but we need more room, so let's move up. All right, let's notice I have our rewritten equations in our solution set here, our little one-sided bracket that indicates a linear system. So let's graph each of them. We are going to graph y equals -x plus 8 by plotting the y-intercept 0, 8. Right? We're going to plot our y-intercept, and then our slope is -1. That means we go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. I'm just going to pick 2 points, the intercept and one other point, and draw a line through them. You could have picked this point here, 1, 7. You could have said, I'm just going to go down 1 and over 1. I like to go down 1 and over 1 a few times so that my points are a little bit away from each other. All right, let's graph the other point, y equals x minus 6. Again, we'll start by plotting the y-intercept, which is 0, -6. Remember, this constant is always your y-intercept. So we'll plot a point right here at 0, -6. And this time our slope is +1. So we'll go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, and plot 2 points. We'll draw a line through them, and we have graphed both of our lines. Now we just have to find the point of intersection, because that's our solution, and it's right there at 7, 1. So the solution to this linear system is 7, 1. All right? If our solution is 7, 1, we're so sure it's 7, 1, we should check that solution. Let's put 7 in for x, 1 in for y in both equations. So we get 7 plus 1 equals 8. 8 does equal 8. It checks in that equation. 7 minus 1 equals 6. 6 equals 6. It checks in that solution, or that equation, making this an actual valid solution to my linear system. Perfect. That's it. That's solving linear systems by graphing. Again, it's probably not the most efficient method, but you will probably be asked to do it when you first start learning these. Still have questions? You should be subscribed to our YouTube channel. Send me those questions. I'll make a custom video solution for you. Till next time, Math Hoppers, take it easy.